Hi everybody, we're looking at chapter 6.2 now, multiplying and dividing rational expressions. Now multiplying and dividing rational expressions, we follow kind of the same process as if we were multiplying and dividing fractions or rational numbers. So for instance, 12 divided by 10 times 5 divided by 4. I'm going to express each numerator and each denominator as products of prime numbers. So for instance, 12, it can be expressed as 2 times 2 times 3. 10, we can express it as product of its prime factors, 2 times 5. Now, we know when we multiply all the entities in the top and all the entities in the bottom. We can cancel out common factors, top and bottom. I got a 2 in the top and a 2 in the bottom. I've got another 2 in the top and another 2 in the bottom, but it's over here. That's okay, multiplication. I've got a 5 in the top here and a 5 in the bottom here. And all that leaves me in the top is a 3, and all that leaves me in the bottom is a 2. Once multiplied, this all simplified down to 3 over 2. Now, if it's similar with division as well, dividing fractions, do you remember? We flip the second one and change it to multiplication, and that's all I've done is flip the second one, so it would have been 24 over negative 40, and I expressed the numerator and the denominators as products of prime factors. I even took out the negative 1 out of 40 as well. Now we'll look for common factors top and bottom. I got a negative 1 in the top here and a negative 1 in the bottom here. A 2 in the top here and a 2 in the bottom here. A 3 in the top and a 3 in the bottom. A 2 in the top and a 2 in the bottom, another 2 in the top, another 2 in the bottom. And all that leaves me with is a 2 and a 5 in the bottom, so I call that 10. Now in the top, it doesn't look like we have anything left, but there's always a 1. There's always a 1. And this simplified down to 1 over 10. So a little review of multiplying and dividing fractions. We're going to apply these principles when we start looking at rational expressions. Okay, so here's another example. We'll use some division here. X squared plus 5x plus 4 divided by 2x squared minus 8x plus 8. Divided by x squared minus 1 over 4x minus 8. Start by factoring. Factor all your numerators and all your denominators. We've got a type 1 trinomial on the top, so we'll factor it like a type 1. You can pause and do the factoring and then check your factoring as you start again. It's very important that your factoring is accurate. X plus 1 times x plus 4. And in the bottom, we'd have 2 times x minus 2 times x minus 2. Greatest common factor first, and then a type 1 trinomial. In the top over here, it's a difference of squares. X plus 1 times x minus 1. And in the bottom, all you can take out is the greatest common factor, 4. 4 times x minus 2. Find your non-permissible values. I'll put them up here. Put them over here. X cannot equal. So from here, if I was to put a 2 into this binomial, I'd end up with 0. So x can't equal 2. Same thing here. But we only have to list it once. And same thing here. Now, it's division. So we have to flip this. And change it to multiplication. In the bottom, we'd have x plus 1 and x minus 1. And in the top, we'd have greatest common factor out, 4x times x minus 2. We've got a new denominator. So we have to take into consideration the non-permissibles for the new denominator. If I put a negative 1 at x here or a positive 1 at x here, I'd end up with a 0. So we have to add those to our non-permissible numbers. We're not allowed to use any of those. Now, it's all factored, so we can cancel out top and bottom or diagonally. I've got an x minus 2 in the top and an x minus 2 in the bottom. 1 for 1. Only 1 for 1. X plus 1 in the top, x plus 1 in the bottom. We have a 4 in the top here and a 2 in the bottom here, so I can take out a factor 2 out of both of them. And I think that all that leaves us with, when it's finally simplified, is 2 times the x plus 4 over x minus 2 and x minus 1. And we'd state our non-permissibles as well. X can't equal 2, negative 1, and 1. Okay. This final expression is equivalent to what we started with. But for it to maintain its equivalency, we have to include the non-permissible values from the expression that we started with.